Okay, hi guys. This is our second video this week, still in section 5.5, still solving exponential equations. We'll do some logarithmic ones next week. These equations I think are a little more straightforward than the ones I did the video on for Monday. These are equations where you're going to look at both sides of the equation and choose a base that you think will work nicely with both of the numbers that are already there. So let's just jump right into these. For this first one, we're going to see that if we use a base of 2, we can rewrite 4 as a power of 2 and 8 as a power of 2. So here we're considering powers of 2. So we're going to rewrite 4 as 2 squared. I'm going to keep that 3x that's there. And we're going to rewrite 8 as 2 cubed. And we're going to keep the power that's there. So that's your first step. Then in this second step, you have to be careful. These are our exponent rules. When you have power to a power, you have to remember to multiply. A lot of you are still adding here, and this should really be multiplication. So when we do 2 times 3x, that gets us 6x. So our power here now on the left-hand side is 6x. Then on the right, we're using the distributive property here. We're taking 3 times x plus 1, and 3 times x plus 1 is 3x plus 3. So you have to remember to do that distributive property. So now we really have rewritten this problem so that it has the same base on both sides. So we have a 2 on the left and a 2 on the right because we chose powers of 2. So now once you're at this point, this becomes really nice because we have the same base on both sides. You can ignore the base and drop it out of the equation altogether and just rewrite it using your exponents instead. So that becomes 6x equals 3x plus 3. So now we just go ahead and solve like you would if you were in Algebra 1. So you move the 3x over. You have 3x equals 3 or x equals 1 as your solution there. So that's a nice easy way to kind of think through that type of equation. So the next one is over here, and for here we have 125 and 25. So for this one, we want to think about powers of 5 instead of powers of 2. So we know that 125 is 5 cubed. So we rewrite that like that, and we keep that exponent, which is 4x. And then 25 is 5 to the second power. And we keep that exponent, which is x minus 1. And then again, same thing as we did over here. We're going to use our exponent rule. So we have power to a power. We're going to multiply those. So we have 3 times 4x, which is 12x. And then here we have 2 times x minus 1. So remember to use your distributive property here. It's 2x minus 2. And then again, we're at that point in the problem where our base is the same on the left and the right, which was our goal. This time we chose powers of 5. So now these are going to drop out, and we're just going to set our exponents equal to one another. So we have 12x equals 2x minus 2. And this is back in Algebra 1 again, so 10x equals negative 2. And x equals negative 1/5 when we reduce that fraction. So like I said, I think these are easier than the ones that we did in the last video. So here are your next few. So for this next one, letter C, we have a 9 and an 81. So we're going to use powers of 9 in this next problem. So this one stays. Just 9 to the 2x. We don't even have to do any work there on the left. And then 81 is really 9 squared. So we're replacing the 81 with 9 squared, and then you keep your original exponent that was there. So now we have 9 to the 2x over here. And then over here, we'll remember we're multiplying 2 times 3x minus 2. That's using the distributive property. 2 times 3x is 6x. And 2 times negative 2 is negative 4. So now again, we have a 9 over here and a 9 over here, which is exactly what we were working towards. And those bases now can drop out, so we can just set the exponents equal to one another. So we have 2x equals 6x minus 4. We're going to move the 6x over here, so that becomes negative 4x equals negative 4. Don't lose that negative right there. And your final answer is just x equals 1. Nice and easy. And we'll do one more like that. That's pretty straightforward, and then we'll look at some with some negatives. So here we have an 8 and a 16. These can both be rewritten as powers of 2 this time. So 8 is 2 cubed. We keep that 5x that was there. And 16 is 2 to the 4th. And we keep the exponent that was there originally. So now remember, we're power to a power. We're going to multiply. 3 times 5x is 15x. And then on the right, we're also going to multiply, but we have to use our distributive property here. So 4 times 3x is 12x. And 4 times 4 is 16. So we got our powers of 2 that we were looking for. And now we just set our exponents equal to one another. So this is 15x on the left and 12x plus 16 on the right. And then it just becomes algebra 1 again. We move this over here. So we have 3x equals 16 and x equals 16 thirds. And you could leave your answer just like that. That's fine. Okay, so those first 4 are pretty straightforward. You don't have any fractions in any of those original problems. They're all whole numbers. So we'll move down now and do some that have a little bit of a different take on them. So for this next one, we know that 81 is a power of 9. And we also have to think about this as being a power of 9. So we're going to rewrite these as powers of 9. So we know that 81 is 9 squared. That's easy. And we have negative 2a plus 2. And we want to think about how we're going to rewrite 1/9. That's really 9 to the minus 1 power, because 9 to the minus 1 moves this 9 to the bottom. So now we're going to remember on the right here, we're going to multiply because we have power to a power. So that's going to be 9 to the minus 4a plus 4 equals 9 to the minus 1. So same thing now, this becomes similar to what we were doing up above. We have our 9 on both sides, which is what we were looking for. And now because our bases are the same, we're allowed to just set our exponents equal to one another. So we have negative 4a plus 4 equals negative 1. Then we move that 4 over. Negative 4a equals negative 5, and a equals 5/4. And that's the end of that problem. So it's a little bit of extra recognition there that you can rewrite 1/9 as a power of 9. It's 9 to the minus 1, which gets you back to that 1 over 9. So for this next one, you know that 6 and 36 are both powers of 6. That means that 1/6 and 1/36 are also powers of 6. We just have to think about them in a little bit of a different way. So 1/6 is really 6 to the minus 1 power. That puts the 6 in the bottom. And we still have 2x as an exponent. Then on the right, 1/36 is really 6 to the minus 2. And that puts our power of 6 in the bottom. And we still have this 3x up here, so we're not losing that. So we rewrote 1/6 as 6 to the minus 1, held our exponent, rewrote 36 as 6 to the minus 2, and held our exponent there as well. And now we remember power to a power is multiplication, so this becomes 6 to the minus 2x. And then on the right, again, we're doing power to a power. Negative 2 times 3x is negative 6x. So we now have our 6 as our base on both sides, which was our plan from the start. Now the 6's disappear, and we can just use our exponents now. So we have negative 2x equals negative 6x. We can add 6x to both sides. That gives us 4x equals 0. Divide both sides by 4, and our answer is x equals 0 for that one. Not too bad. Once you start to recognize that you can use these negatives, it becomes a little easier for you. So I just have one more for you. 625 is a power of 5, and so is 1/5. So we're going to use powers of 5 for this problem. So 625 is 5 to the 4th power. If you don't know that off the top of your head, that's okay. You can use your calculator to come up with that. 1/5, just like we've seen up here with these earlier problems, is really 5 to the minus 1 power. And our exponent stays at 2a plus 2. So now we're going to multiply because we have power to a power. This becomes 5 to the minus 4a. Don't lose your negative sign. And this becomes 5. We're going to multiply negative 1 times this quantity out here. This becomes negative 2a minus 2. It's really important that you hold your negatives with these problems. So now we have a 5 over here and a 5 over here, and we've rewritten it using powers of 5. Once you do that, your bases can disappear, and you just use your exponents. So it's negative 4a equals negative 2a minus 2. You can pull this 2a over here using addition, and you have negative 2a equals negative 2, which when you divide both sides by negative 2, you get your final answer of a equals 1. So those are our example problems for today. Again, this is section 5.5. This is the second method in 5.5. You should now be able to complete your second assignment for this week. I hope you already looked at the other one, which was the first method that I did on Monday. Please make sure that you submit both of these by Friday. Try not to wait until Friday to do all of your work. And as always, if you have any questions, please email me. I'm happy to do any individual conferences with you to help you out. Okay, I hope you guys have a good week. Take care.